Hello, this is Ms. DB, and this is part 2 of section 8 of chapter 1 on exploring transformations. You should have already finished part 1, which was to do some translations and some reflections using Sketchpad. Our objectives today are to apply transformations to points and sets of points, and to interpret some transformations of real-world data, and also of some functions. A transformation, definition of a transformation, is a change in the position, size, or shape of a figure. And one type of transformation is a translation, and we already learned about that. That's a slide that moves each point in the figure the same distance, the same direction. It's just moving from one place to another. That's a translation. We start this section with a review of translations. We can translate just a point. In this point, right now it's at -3,4, and they want to translate it 5 units to the right. So they're just going to move that point 5 units to the right, and now it would be at 2,4. So the y-coordinates didn't change, the x-coordinate changed. If you took -3 and added 5 to it, then you would get 2, just like they got. And you should have found that out in part 1 when you worked with this in Sketchpad. You can also, with the translation, you can move in more than one direction. For this translation, you're going to move 2 units left and 2 units down. So they went horizontally 2 units left and vertically 3 units down. And the new point would be at -5, 2. So the rule would be you take your x-coordinate and move 2 units to the left, take your y-coordinate and move 3 units down. So we went x -2 and y -3. Alright, so horizontal translation changes the x-coordinate like we just looked at, and a vertical translation changes the y-coordinate. And here's the rules like I just started to write. If you start with a coordinate, x, y, and you are going to translate horizontally, you will be adding something to the x-coordinate. If it's moving to the left, it'll be a negative number, less than 0. If you're moving to the right, that'll be a positive number. For a vertical translation, you'll be changing the y-coordinate. You'll be adding a number. You'll be adding a positive number if you're going up. You'll be adding a negative number if you're going down. All right, you also looked at reflections in part 1. That is when you flip a figure across a line. And that line has a name. It's called the line of reflection. Each reflected point is the same distance from the line of reflection, but on opposite sides of that line. When you have a reflection across the y-axis, the x-coordinate changes. So if you started out with -1 and you reflected about the y-axis, now it's going to be +1. So when you reflect about the y-axis, the x-coordinate is the opposite. Is opposite sign. If you're reflecting about the x-axis, then the y-coordinate will have the opposite sign. Coordinate. So if you are reflecting about the x-axis, the y-coordinate will have opposite sign. So if it was positive, it'll be negative. If it was negative, it'll be positive. You can transform a function by transforming its ordered pairs. So you can just use those rules that you learned to translate or reflect points. And when you do that, the original graph and the new graph are going to be congruent. They're going to be the same shape and the same size because it is what's called an isometry, when it preserves the same shape and the same size. You probably learned about transformations in your geometry course or even your Algebra 1 course. All right, in this problem, we are going to take this function right here, this kind of a M shape, and we are going to translate everything 2 units up. The easiest way to do this is to make a table. Here's our original coordinates. We had a point at -5, -3. We had a point at -2, 0. We had a point at 0, -2. And if the points aren't given to you, you can just put some nice points on the graph. You had one at 2, 0, and there was one at 5, -3. So we wrote down those coordinates in the table. And then they wanted us to translate 2 units up, and the rule is then that we would take and add 2 to each of the y coordinates. Now our x coordinates are not going to change because it's a translation only 2 units up. We're not going left or right. So our new coordinates are going to be -5, -1. That's going to be our first new coordinate, -5, -1. And we'll do that to each of our coordinates, each of our points. We'll move each of them up 2 units. And this one was 2, 2, and this one was 5, -1. And you can plot each of your coordinates and then connect them to make the same shape. Here's an example of reflecting across the x-axis. Now remember that when you reflect across the x-axis, the x-coordinates aren't going to change, but the y-coordinates will be the opposite sign. So we're going to identify the important coordinates, which we are the same as the last time. And then we are going to find the new y-coordinates by taking just the opposite sign of each one. So -3 becomes 3, 0 stays 0, -2 becomes +2, and so on. Then we can graph our new points. So our first one would be -5, 3. So here's -5. It would be right there. And our next point would be -2, 0. Look, that point didn't change. Any point that's on that x-axis isn't going to change. The next one is 0, 2. The next one didn't change again. It's still 2, 0. And then our last one is now 5, 3. And then you connect those and you get the shape, the graph that is reflected about the x-axis. All right, so this is part of your worksheet here. You're going to be able to answer some of these questions. We already talked about number 1. You can look back towards the beginning to see what a transformation is. Number 2 says, how will the coordinates change if the function is translated 3 units to the right? So are the x coordinates going to change, or are the y coordinates going to change? And will they change by adding 3 or by subtracting 3? Number 3 says, how will the coordinates change if the function is translated 5 units down? So again, is it going to move vertically or horizontally and by a positive or negative amount? Number 4, how will the coordinates change if the function is reflected across the x-axis? That's like we just talked about. Across the x-axis, is it the x coordinates that change, or is it the y coordinates that change? And then finally, how will the coordinates change if the function is translated 2 ways, 4 units left and 2 units up? So you might say that the coordinate xy will become x, is it going to be +4? Is it going to be -4? Is it going to be +2 or -2 to do 4 units left? You pick the right one of those. And then the y-coordinate, oops, I put my parentheses too soon. The y-coordinate is also going to change. Is it going to be y +2, y -2, y +4, y -4? These two things tell you how you are going to be changing your coordinates. You'll also be asked to translate a point on a graph and give the coordinates of the translated point. So you're asked to do this in Sketchpad and then give the new coordinates. I mean, not in Sketchpad, in Word. It's a worksheet in Word. So to go 5 units left, let's first write the coordinates of the point right now. This is 1, 2, 3, so x is 3 and it's up 2. So right now our point is at 3, 2, and we want to move to the left. 1, 2, 3, 4, 5. So here's our new point, and we would end up at -2, 2. So I can tell by looking at the graph, or I could say, well, I just have to subtract 5 from each x-coordinate, leave the y-coordinate the same. 3 minus 5 is -2. Now in Word, you can go to, let's see if I can get there from here. I'm going to open up a Word document and show you how you could add a point. This is the worksheet that you have to do. And here it is right here. If you want to add a point to show that you've moved 5 units to the left, let's show the whole thing here. You want to go to Insert at the top, and then Shapes. And they don't really have a good point one. They have some funny stars. I would just use a circle. So under Basic Shapes, there's kind of an oval thing, but that it's really, you can make it be a circle. And I'm just going to draw 1, 2, 3, 4, 5 right here, tiny circle. Now my point automatically filled in. Maybe I set it that way. It's also got funny little shapes on it. I'm going to draw another one. Insert, Shape, pick the oval, and this time I'll just do the 3 units down one. See, it's got this selected, which might mess me up. 1, 2, 3. Oh no, I can still draw one. You can move this around too, which isn't going to help you out any. Where did that go? Right there. Okay, so when you have your circle that you draw, let me make it bigger so you can see, there's things that you can do to it. You can format it with different fill, different colors and stuff. You do not have to mess around with this. I just need a circle. It doesn't have to be filled in. Once you have one of them, you can copy and paste it. I just selected it and did Control-C, and now I can do Control-V and get another one. So the next time I need a point, I can move it around. You can change the size of it, make it bigger or smaller. That's way too big for our graph. But that's how you can add a point to a Word document. So you're going to do that for each of these problems, add them, and give the coordinates of the new point. So for the coordinates, you use a parentheses, and then you put the x-coordinate, comma, and then you put the y-coordinate. And then you have to do the coordinates for each one of these. All right, I'm going to go back to our PowerPoint. The next questions on your worksheet ask you to take this V-shape absolute value function, and it has been transformed in 4 different ways. And you are going to decide whether that each one of these is a reflection or a translation. And there's one of them that can, maybe 2 of them that can be either a translation or a reflection. And then you're going to say, how has it been translated or how has it been reflected? So the first thing to do for each of these is to pick reflection or translation. So for A, it has been flipped over. You can tell that it hasn't just been moved. It wouldn't open downward then. So it must be a reflection. So on your worksheet, you can highlight or you can underline or you can turn this one a different color. Or you can delete the translation, but it's going to be a reflection. Here's the function. If a translation continues, so I don't have to do this part because it's not a translation. So this line doesn't apply because I decided the letter A was a reflection. But then I have to finish. It's a reflection, so I have to continue. Is it about the x-axis or the y-axis? Well, it was flipped over the x-axis. So I have to fill that in too. So B looks to me like it would be a translation. It looks like it moved over. So then I'm going to circle translation or cross out reflection. And then I have to do the second line because it's not a reflection, so I don't have to do this one. So you have to pick the proper one. If it's a translation, continue. How many units left or right? Let's see. It definitely moved to the right. The vertex was at -3, and now it's at 3. This is one of the ones that could be a reflection, but I picked translation, so I only have to fill this out. So it moved 6 units because it went from -3 to 3. Right, and not left, right. Did it move up or down? No. So 0 units up or down. Number 3, or C, you have to do that one. And then D is both. D has 2 things happening to it. There's a reflection and a translation, so you have to decide both of those. It might be easiest to reflect first and then figure out how far did the vertex move. Look at the vertex here. This one's at -3, 0, and this vertex is at, I believe it's at -5, 0. So you can tell how that point moved in order to answer the part about the translation. Okay, there are other kinds of transformations, and some of those are stretches and compressions. Now, our book describes a stretch if you pull the points away from the y-axis. And it's called a compression if you push it towards the x-axis. Here's an example. All right, so a horizontal stretch is if you pull each point away from the y-axis. So we started with the blue, and then we stretched it by pulling this way, away from the y-axis. A horizontal compression is if they pushed it towards the y-axis. So they're like squeezing it in. That's a compression. The vertical stretch is when they pull away from the x-axis. So they pulled it up and away. And the vertical compression is when it has been pushed towards the x-axis, so like pushed downwards. These ones are a little bit harder to do by hand, but with a table of values, it's not so bad. All right, so this one says that we're going to have a horizontal stretch. Let's look at a horizontal stretch first. Horizontal stretch should change it like this. Okay. By a factor of 3, graph the function and the transformation on the same coordinate plane. Well, the function's already graphed. Now we're going to pick some points, and these are the points. This is the part you would do first. This would be the blank part over here. Then you multiply all of the x-coordinates by the factor of 3, by 3. So -1 times 3 is -3. 0 times 3 is 0. 2 times 3 is 6. 4 times 3 is 12. So my new points are going to be -3, 3, 0, 0, 6, 2, and 12, 2. So we put our new points on our graph, the same graph, -3, 3, 0, 0. That one didn't change. 6, 2, and the other one is way off the screen at 12, 2. So you can see how it's been stretched. Oh, and yeah, you can't really, so the red line, this got pulled, and then this is the curved part, it curves way more, and then it would go way off the screen. So stretched out. Here's some from your worksheet. So first, the translation one, that one's a little bit easier. You're going to translate left 1 unit and down 5 units. So every x-coordinate is going to get 1 subtracted from it. And you can put your new x-coordinates over here then. And every y-coordinate is going to have 5 subtracted from it. So 3 minus 5 is -2. Now, instead of having to graph this, you are supposed to describe the graph. If you want to graph it, you could graph these in Sketchpad or on your own coordinate graph paper, like grid paper. But you could also just do it on scratch paper and then see what it's going to look like. So we already know that a translation left 1 unit and down 5 units is going to, the whole graph is going to move 1 unit left and 5 units down. So this one we could graph since we have it I have a pencil tool here, but every one of these points, -4 to -2, sorry. So here's one of the points going to be, because it moved down 5 and it moved to the left 1. So this point moved to here. For the vertical stretch, the horizontal compression, and the reflection across the x-axis, I thought we'd look at one of those now. All right, we are going to do a vertical stretch, which means that we are going to take our y-coordinate and multiply all of our old y-coordinates by 3/2. If you prefer, you could use 1.5 times y. So -3 for the x-coordinate is going to stay, but our new y-coordinate, I don't know why it's making those weird lines, our new y-coordinate would be 3 times 3/2, which is 9/2, which is 4.5. Let's change that to a decimal. So this first one is going to be 4.5. So in Sketchpad or on your own paper or somewhere, we can graph our original function, -3, 3, and then our next point is at -3, 4.5. So this is 5. So, hey, where did it go? Only one point allowed at a time here. There, they're both there. And then we would do the next point, -1 is our x-coordinate, that'll stay the same, and the y-coordinate will change to 1.5. So I should be using different colors here. Our new coordinate would be -1, 1.5, and our old one was -1, 1. And then there went the new one. So you'll do that and you'll see that they'll kind of be a ghost of each other. That the vertical stretch will, all the x-coordinates will be the same, but the y-coordinates will be stretched away. They'll all be just a little bit bigger. So your description, you don't have to show me the graph. Your description would be, you could even write that, exactly what I just said, or x-coordinates will be the same, but all the y-coordinates will be a little bigger. And it's been stretched kind of upwards. There's a couple at the end of your worksheet where you just have to say, these are going to be either translations or reflections. If it's a translation, you have to say, is it up, down, left, or right, and by how much? It can be more than one thing. Maybe it's, red is the original. So the red is the original. It looks like it went down to get to the blue. A good idea is always to look at the vertices and look from one vertice to the other. How did it change? And then if it's a reflection, you have to say, is it over the x-axis or over the y-axis? So where could I fold it so that you would get the exact same thing on both sides? That's the line of reflection. All right, well, good luck. Have fun with this one. And let me know if you have any questions. Thank you.